Okay, in this video, we're going to find the images of these complex numbers. N is runs between 0 and 5. This is under the action of the complex exponential function. So our f of z is e to the power z. So that's in part A. And then in part B, we are going to find the image of the horizontal straight line z equals to x plus pi I. These points are actually part of this straight line. Okay, so let's get straight onto it. So first of all, z equals n plus pi I. So when n equals to 0, z naught is going to be simply pi I. z1 is going to be 1 plus pi I. z2 is going to be 2 plus pi I. z3 is going to be 3 plus pi I. z4 is going to be 4 plus pi I, and lastly z5 is going to be 5 plus pi I. So let's just make a sketch of how these numbers are going to where they're going to be located on the complex z plane. So you notice that all of them have the imaginary part of pi I. So this is why here. So these are going to be located on the horizontal straight line y equals to pi. So first one, z naught is going to be on the vertical axis. Then of course z1, so this is 1 here, z2 is 2 here, z3, z4, and z5. Okay, so they're all along the horizontal straight line, which is specified here. So that straight line is the same as y equals to pi. So we will see what their images turn out to be, and we will plot them on the W plane. So this is Z plane this side, this is going to be the W plane, or we plot our images. Okay, so let's get straight onto it. What's going to be the image of Z naught? So image of Z naught we call W naught. So we get that by simply plugging in Z naught in the exponential function. It's going to be e to the pi I. E to the pi I is just -1. So just in case you need a refresher on this, it's going to be cosine pi plus I sine pi. Cosine pi is -1, sine pi is 0, so that's simply -1. So that means the image of Z naught is going to be on the horizontal axis here, a distance of 1 from the origin. Then W2 is going to be e to the power 2 plus pi I, going to be e squared times e to the pi I. E to the pi I we've already worked out as -1, so it's going to be negative e squared. So that's going to be W1 distance of e squared from the origin. Okay, so okay, the distances here in our plot are not necessarily to scale, because if this is 1, then e squared is 2.8 squared is going to be much further than that. Okay, but we're just going to plot them such that they all fit. Then sorry, this is W2, or we missed W1. Okay, and with W3 going to be e to the power 3 plus pi I, going to be e cubed times e to the pi I negative e cubed. So that one is going to be further along. So let's call this one W2. So W3 is going to be somewhere there. Let's go back to W1. So W1 e to the power 1 plus pi I, going to be e times e to the pi I, going to be negative e. So let's say that's that one there. And then W4 going to be e to the 4 plus pi I, going to be e to the power 4 e to the times e to the power pi I. It's going to be negative e to the power 4. So that's W4. Now you can see that all of them are actually lying on the negative real axes. The final one is going to be W5. So W5 is going to be e to the power 5 plus pi I, e to the power 5 times e to the power I, pi I. So it's going to be negative e to the power 5. And so that one is going to be located further along here, W5. Okay. So what is this thing saying? This thing is saying, just going to make a little sketch here. This thing is saying that this line, because it started here, this line here, it is suggesting that this line, or maybe let's do the calculations for part B, but basically so these numbers here are transformed onto those numbers there. So this one onto this one, this one. So while here they are from left to right, here the images are from right to left. This is a horizontal straight line, but as well here still there on a horizontal straight line. Okay, so the next question says, what is going to be the image of z equals to x plus pi I? So let's just deal with that and then we'll generalize. So part B, z equals to x plus pi I. So if we plug that in here, it's actually the generalization of what we're doing here. It's just going to give us e to the x times e to the pi I. E to the pi I is negative 1. So this is just going to be the negative of the exponential of x. And this is a real negative number. So that means all the points on this horizontal straight line, by the way, I said this is the same as y equals to pi. Let me just work through that in case someone is asking themselves how that comes about. Well, z here is x plus iy. So if we write x plus iy here equals to x plus I pi, and then of course the x's we can simply cancel out, and so this is now implying that the coefficient of I on both sides is the same. So y equals to pi is the equation of the straight line. So that straight line, so that's the straight line here, its image is also going to be a straight line, because so this is y equals to pi, then its image is going to be the negative real axis. So the numbers on this straight line are going to map onto the numbers on this straight line here. Okay. 0 is not going to be part of this, because this value never gives us 0. So this one, when x is 0 here, that is going to give us -1. It's -1 here. Then when x is 1 here, this is going to give us -e. So that's going to be somewhere there. And then when x is 2, that is going to give us -e squared. When x is 3, it's going to give us -e cubed, etc. Then when you go this side, when x is -1, this is going to be now the reciprocal. So it's going to be less than 1. So that's going to go somewhere there, 1 over e. When x is -2, then it's going to be -1 over e squared. So basically what this thing is saying is that this side, the right hand side of this line, the right hand side of this line, and this bit here is going to map onto this bit here all the way to infinity. And then this bit here is going to map, so that infinite length line is going to map onto this finite length line. So all the points here are going to map onto just that stretch, and then all the points this side are going to map onto this stretch. But end of the day, this line of that goes to infinity this side and infinity that side, it's going to map onto this half line, only goes to infinity this side. So that is what is going to happen, and that is the answer for part B with a bit of explanation. All right, so for now we're going to ask you to go and have a go at number 3. Number 3 says find the images of the complex numbers, these ones here. Now you're going to notice that these ones are similar to what we did in number 1, only that in number 1 we had 1 here. So in this question, that 1 is not there. Okay, then find the image of the line x equals to 0. Then from there deduce the image of the region x is less than 0. Then in number 4, you're given this rectangle here, with 4 vertices. The vertices are given 1, 2, 3, and 4. This is pi I. Find the images of the vertices first. Then after that, find the image of the shaded rectangle and make a sketch. So I'd like to have a go at that. That would be great. In the next video, we will provide the solutions for that. Thank you for watching.